Hey guys, welcome to this virtual lecture that I've put together. I intended to go over this material in class last Thursday, our first week of beef kill, but we just didn't get there and I thought it might not be as productive to get everyone in a group again as we were finishing up. So I put together this video. It'll be fairly short and I think it will allow you some time to reflect on the information provided and utilize that again on Thursday. So be sure you watch it before Thursday. If you know of your classmates who may have not watched it, encourage them to do so. But we'll go ahead and talk about specified risk materials. The reason I'm talking about it now is because it specifically pertains to cattle. So what are SRMs? SRMs are tissues in cattle that are considered to be of high risk for prion contamination. We are really only focused on SRMs for cattle. That doesn't mean sheep do not have that risk for prion. They do. That's where we get scrapie from, but scrapie has been eradicated and is not really an issue in our country anymore. So we are again focusing on cattle. Hogs, we have not identified any prion in hogs that would be area of concern for us if we consume pork. And looking at what a prion is a protein that changes shape somehow in the body. It's not yet known and affects the brain. So it's a disease of the brain, and we call the group of prions TSE, transmissible spongiform encephalopathies. If we're looking at cattle specifically, we are looking at BSE, or bovine spongiform encephalopathy. So this group of TSEs causes a disease state in the brain. It's a nervous system disease, which is where we're going to see nervous clinical signs. In the human, because it is transferable to human and can be found in human species, it's called Creutzfeldt-Jakob disease. So if you do consume meat that has the BSE or TSE prion, that can develop into a disease state in humans. If you've heard of mad cow disease, this is exactly what we're talking about. We have not really seen any incidences of BSE in the United States cattle population because it is very heavily regulated and very well studied. The last cow that I am aware of, is a pretty famous cow that was found to have BSE, was in 2003. If you've heard of the cow that stole Christmas, this cow was identified, tested positive for BSE prion on December 23rd of 2003. That really set the beef industry into some finding ways to deal with that issue. Huge economic losses, loss of trade markets internationally, so a huge impact on the beef cattle industry and the meat industry. So as far as what we think of as SRMs in our case, when we are on the harvest floor, they must be removed. Okay, so we have to identify the SRMs and remove them in a specific way as outlined in our SRM guide through our HACCP plan. This is dictated through 9 CFR 310.22. That just is the Code of Federal Regulations, the laws that govern our processes. Are dictated by the USDA, and that's what the 9 is symbolized by. And so in that CFR, you can find all of the details about SRMs and why we have to remove them. We have to remove all the SRMs, but they're variable dependent on age. So if you were involved with cleaning the head on the kill floor, you also probably were instructed by either myself, our inspector, or a meat lab employee to identify the age of that carcass based on dentition. So if anything less than 30 months, we handle SRMs differently than anything over 30 months. I'm going to start by talking about determining carcass age, just so we're all on the same page. We can determine age one of 3 ways. First is through age verification records. If whoever bought us those cattle on Thursday or in the weeks to come can provide accurate, verified age records for those animals, we can use those to say those animals are less than 30 months of age or more than 30 months of age. If we're thinking about age, any feedlot animal, any typical feedlot animal that hasn't been in there in over extended period of time, those animals should qualify for under 30 months. Any cull cows or bulls or extendedly fed animals, say if we're trying to achieve a Wagyu type product, those animals are fed quite a long time, they will likely fall into the over 30 months of age category. Let's say we don't have any age verification records. Then we can use dentition to assess age on the kill floor. This is most commonly used in today's commercial beef industry. The beef plants pay an employee every shift to look at the teeth of every carcass that goes by. So we look at the incisors, not the molars, so that'd be the front bottom teeth, not the back ones. So we don't have to stick our hand in there, we can just visually observe. And we're looking at what those incisors look at. I have pictures of that, so just hold your breath for now. The last way to determine carcass age is by the skeleton. This we do not do on the kill floor, just because the carcass has to cool before we can accurately assess the skeleton for age, but I will go over some of those principles, especially for you, Houston, who has some interest in beef grading. This will be pretty handy for you to know. So looking at some different teeth, we have those incisors, we have deciduous 1s, deciduous 2s, deciduous 3s. So those are the front incisors. We number them based on the pair. So the first two are 1, next are 2s and 3s. So these are all young baby teeth that you're seeing right now. We know that because there's plenty of space between each teeth. They're smaller teeth. If you were to handle them, they'll probably be pretty loose in the gum. So this is indicative of an animal that is less than 30 months old because they have all their baby teeth. In comparing an animal that is less than 30 months old to an animal that is over 30 months old, or baby teeth versus large grown teeth, we have those baby teeth at the top. Again, lots of gaps in between. They're more cone-shaped down into the gum, and they'd be loose if we handled them. The older teeth are larger, wider in shape, have less gaps in between, and so there are some really size differences that we can see. So how do we know, at what point do we see baby teeth fall out and permanent teeth come in? So here is an example of teeth set 1. So the first 2 incisors are permanent. I can tell that because they are large. They are attached more to the gum, and they have baby teeth surrounding them. Very apparent differences. So if we see a carcass next Thursday that has 2 permanent incisors and the rest are baby teeth, that is considered less than 30 months of age. The second permanent incisors start to erupt through the gums between ages 24 months and 30 months. Okay, so we see both right and left permanent incisors, set 2, coming through the gum line. Okay? As soon as we see one or both second permanent incisors erupting the gum line, that is then considered over 30 months of age. You may be asking yourself, well, Mackenzie just said those second incisors may not come in until 24 months of age to 30 months of age. The USDA hinders on the side of caution. So if we're seeing those, we don't know if it's 24 months old or 30 months old, and that 30-month mark is where we draw the line. So in looking at the heads, and I believe we'll have some cull cows again in our weeks of beef kill, I want you to start to think about how you can use dentition to assess carcass age. Here again is just another example of full set of permanent incisors. This is a very old, mature cow that has come through a facility. Don't be confused by this image. This is what we call a gummer, or an animal that has lost basically all of its teeth. This cow would be extremely old, probably pushing that 10 to 12 year mark. She's just lost all of her teeth, and so she was probably cold for that reason. She wasn't able to keep body condition on because those permanent incisors aren't going to allow her to graze as effectively. So back to the skeletal assessment of carcass age. Again, we're not going to do this on the kill floor for us, but if once you're looking at a cooled carcass, we can assess ossification of the cartilaginous buttons of the first 3 thoracic lumbar or thoracic vertebrae. So that was a mouthful. When we assess a carcass, we're looking at the split chine bone. So when we take that saw, we're splitting in half, we can see the skeleton, particularly those dorsal processes along the rib cage. So we're looking at the top of these vertebral column, these dorsal processes, they all have cartilaginous buttons, and you can see those. The cartilage is indicated by white. Bone is kind of a brownish, reddish, porous material. So as an animal ages, these cartilage will ossify or turn into bone. This happens around 30 months of age. We'll start to see initial ossification, and as we get to a really old cow, they might be completely ossified. So this is mainly for grading purposes. So we're going to stamp a USDA choice versus USDA prime stamp on that carcass. We would look at the buttons. For inspection purpose and identifying age to remove SRMs, we are strictly going to stick with dentition or age verification records. Going back to SRMs, now that we know how to evaluate age, if we have cattle that come through that are less than 30 months of age, we only have to remove 2 SRMs, those being the tonsils and the distal ileum. In talking about the tonsils first, that has everything to do with the tongue. So if we are keeping tongues as a variety meat for consumption, which is very normal, we have to cut the back part of that tongue off, and that becomes waste and is not for sale. We are specifically looking at these 3 tonsils: lingual, palatine, and pharyngeal. And so we would make a cut right here and sell the front portion of the tongue, and the back portion is waste. At the Utah Meat Lab, we do not sell tongues, so we don't ever have to do that. The inspector would look at all of these tonsils, make sure they're normal shape, normal color, normal size, and once he's done, then we just toss the whole tongue. Next is the distal ileum. Okay, so think back to your anatomy and physiology. If you've taken that, the ileum is the 3rd section of the small intestine. Distal meaning furthest away from the center of the body. So this distal ileum is the last 80 inches of the small intestine, measured from the ileocecal junction. Okay, so this white arrow you see in the picture here is the ileocecal junction, meaning the junction between the ileum and the cecum. Cattle don't have a huge cecum, it's just the first part of the large intestine, but that's where we get small intestine versus large intestine. So we're going to measure the first 80 inches of unstretched small intestine, and that would be considered an SRM, and it has to be removed. Again, at the Utah Meat Lab, we do not save intestines. They all go to waste, so we don't actually have to go in and remove that distal ileum. An instance where we would save or remove it so we could save the rest of the intestines is if we're trying to save the organ for casing manufacture. So we clean them out, put an antibacterial in there, and make sure that we can use it to stuff a ground product in for things like breakfast sausage. The reason I've always asked myself, and only recently realized, why the distal ileum? Why is it that specific section that is considered an SRM? The distal ileum houses Peyer's patches, which is involved in nutrient absorption. The entire ileum actually has Peyer's patches, but research has found that more infection of that prion happens in the distal ileum than the duodenum or the jejunum, and that is why we specifically look at the distal ileum. But the definition of SRMs is not universal. It changes from country to country and regulation to regulation. So in the European Union, none of the small intestine can be saved for human consumption. So we will never get sausage casings from cattle that originate in Europe. In the US, we're only looking at distal ileum. However, I found an interesting research article that really looked further into where the prion affects Peyer's patches or the enteric nervous system. And in that research project, they took a sample from the ileocecal junction, the distal ileum, and then the 2 sections of the jejunum. And they found infection in the jejunum. And they had cattle at different months past infection. So within a year, the infection is really localized to the ileum, but cattle over a year, typically we see some infectivity of the jejunum. So that leads me to wonder if our SRM definition is inclusive enough, and if so, where does that research start in terms of changing the 9 CFR 310.22? Okay, so now let's say we have an animal that is over 30 months of age. There are additional SRMs that we have to remove. So the skull, brain, eyes, and trigeminal ganglia, that's all associated with the head. Trigeminal ganglia is lymph tissue right below the hypothalamus, so it would be involved in the brain. So if we remove the whole brain, we should be fine. But the question that comes up is, how does this affect the head markets? We at the UW Meat Lab do not sell beef heads. However, other facilities commonly sell heads, and it's a great use of a byproduct. Definitely ethnic cultures tend to prefer them more than your traditional North American cuisine. So we can't sell a head if it comes from an animal over 30 months of age. That could affect our byproduct costs or economic situation. So it's something to think about as a meat processor. If the UW Meat Lab wanted to try to bring in some more funds by selling the head, that might be a good option because most of what we slaughter are less than 30 months of age. Next is the spinal cord. This is something I want to point out specifically because really we don't have to remove spinal cord on anything less than 30 months of age. But for those of you in the first group, I guess Connor and Ryan, you were instructed to remove the spinal cord, even though the animal you were processing was less than 30 months. So most plants, as a GMP or a good manufacturing procedure, will remove spinal cord on everything, no matter the age. And so you'll see the picture here. This is a vacuum that vacuums out the spinal cord. That is very commonly seen in large beef plants. So when we go to Cargill at the end of the semester, we'll be looking for that. For us, if we just take a knife or a spinal cord remover, we can just pull it all out. This becomes a problem if we don't split that beef carcass right down the middle. So again, people who are splitting carcasses at the plant usually wear black hard hats, and that indicates they are being paid the most or the highest hours or dollars per hour to be working at that facility. And so if we can't quite get the spinal cord out because the split is off, we can high pressure wash it out or try to break the chine bone as much as we can to remove that. Next is the vertebral column and the dorsal root ganglia. So any animal that is over 30 months of age, we have to put purple ink, which is food grade, so we can consume it. Purple ink has to be painted in that spinal column, and that's the universal sign that any retail cut from the animal has to be boneless, meaning we cannot keep any of the bones. Now I say boneless, most over 30-month cattle is creating boneless cuts, but by definition through USDA, we could make some semi-boneless cuts by keeping just the far most outward portion of that transverse process. So we would make a cut with the bandsaw on the fab floor, right where these red lines are, remove this vertebral column, and then we could keep some semi-boneless cuts off of, say, the New York strip steaks or some ribeyes. That does not often happen. It's easier just to go ahead and remove all the bones and market it as boneless product. Now, the reason we have to cut so far out is to make sure we remove any dorsal root ganglia. So we see here, this is spinal cord, and then we see dorsal root ganglia protruding out of the side of the spinal cord. So this is essentially where the central nervous system articulates with the peripheral nervous system and nerve signals are transferred. So again, a prion disease is a disease of the central nervous system, so we have to remove that spinal cord and associated tissue. Last thing I want to cover is we're trying to remove SRMs to prevent the transmission of BSE, which can turn into human form Creutzfeldt-Jakob disease. We do all of these things in cattle that appear very normal through ante-mortem inspection. However, we can identify or flag an animal as U.S. suspect for BSE concern through ante-mortem inspection. I've listed the signs that would appear in an animal that's affected. The biggest one is increased licking of the lips or the nostrils or the tops of the hooves, scratching the head on fence posts or gate panels, abnormal scratching, because all cattle are probably going to do that at some point in their life, but excessive scratching will be a big one. And then sensitivity to stimulants, so ear twitches or muscle twitches from little amounts of light or sound. Those are the common signs of ante-mortem inspection that we would look for BSE concern. However, we have not seen BSE in the last 16 years, so very, very uncommon And so it's likely we're not going to catch it on the antemortem, but we might catch it through the postmortem. And we don't do any tests. We don't do blood tests or chemical assays to identify it. It would just be through transmission into a human subject and trying to figure out where that came from. So it's a pretty advanced disease state that causes the beef industry quite a bit of problem, and that's why we adhere to removing the SRMs like we do. So with that, I will see you on Thursday. Come with any questions, because I know I still have some about BSE and hope to have a discussion with you then.